Hello students, today we are going to discuss about the velocity of longitudinal waves in non-elastic medium. We are going to find out that velocity of longitudinal bond. Okay, so last class we can discuss about the velocity. So velocity depends upon the tension of the string and linear mass density. So velocity of stretched string we can calculate. So this class we are going to discuss about that velocity. We are going to find out that velocity of longitudinal waves. So consider one piston or cylinder. Consider one cylinder. This cylinder contains some liquid or air, whatever may be. Okay, liquid or air. So this will be producing that longitudinal waves. So one end is producing longitudinal waves and another one end is fixed with one piston. Okay, one end here, one end is there. So this end is fixed with the longitudinal, one end is producing that longitudinal waves and another one end is fixed with one piston or this longitudinal waves produced by the tuning fork. Okay, so when tuning fork strike out any one material and you can place here, so it will be producing that longitudinal waves. Okay, so consider this the one piston. This piston, in this piston contains the one elastic medium. That elastic medium density is rho, and the cylinder having area A, and this cylinder maintaining at the pressure P. So density of that air or liquid or any one elastic medium, the density is rho, and A is the cylinder area of that cylinder, and rho is P is the pressure. So this cylinder maintained under a condition of this pressure. Okay. Now this piston. Okay. This piston is moving some velocity with some initial velocity u. Okay. So this piston is moving some initial velocity. So this is the point and this some distance. So what is that distance means? That is del D. So here that piston is moving so up to this distance, del D distance. Okay. So with a velocity of u. U is the velocity of piston alone. Okay. U is the velocity of piston. So what about this? That elastic medium also moving. Okay, so that elastic medium is from here. That elastic medium is also moving. So that velocity is V. V is the velocity of elastic medium. U is the velocity of piston. And here V is the velocity of elastic medium. V is the velocity of elastic medium and U is the velocity of piston. Okay, so how much distance it is moving? So del D distance. So that distance we have to calculate. So velocity is equal to, what is the formula? Distance by time taken. Okay. So distance by time taken, then distance equal to velocity into time. So distance is equal to, what is that? Del D. And velocity is the piston alone, it's moving. So del D is equal to U into del T. Okay. Then next here that elastic medium also moved. So it covers some distance. So that distance is called del X. So del X is equal to, what is the formula? Velocity into time. So velocity, the elastic medium velocity is V into time, that is del T. Del X is equal to V into del T. Okay. So next I am going to calculate that mass. So what is that mass? Mass of this liquid or air. So mass of medium. We want to find out that. So how to calculate that mass of medium? So density is equal to mass per volume, and density is equal to mass per volume, then mass equal to density into volume. Okay, so that mass here, that mass is changing mass because the piston is changed. some distance is moving. Okay, so the distance is varied. So distance varied means that mass is also varied. Okay, so only I can take the del m. Del m is equal to density into volume. So volume is equal to what is the formula? Area into some distance. Density is equal to area into some distance. So area A. What is the distance? What is the distance that medium is moving? A into del x. Then A into del x. Del x is equal to what is the formula? V into del t. So rho A V into del t. So del m is equal to rho A V into del t. Then next del m is equal to rho A V into del t. I am going to find out that changing momentum. Changing momentum is equal to changing mass into velocity u. So momentum is equal to mass into velocity. So del p is equal to del m into u. Then del m, what is the formula? Rho V A into del t. This changing momentum is called as an impulse. The changing momentum is also known as the impulse. So impulse is equal to, what is the formula? Impulse equal to one of the force into time. Okay. So at the very short interval of time, a very greater force is acting means that is called as an impulse. So I is equal to F into T, or I is equal to force into del T. Here force equal to changing pressure into area. So changing pressure del P into A. So del P A into del T. Okay. So I is equal to del P A into del T. So I is equal to del P. So del P is equal to rho V A into del T. You can substitute here. So rho I is equal to del P A into del T. So from this equation you can now equate these two equations. I is equal to del P. I you can substitute del P A del T is equal to del P is equal to rho V A into del T. So here A del T cancel. Then here del P is equal to mass into velocity u. So u is also. But del P is equal to rho V U. So this del P is known as the, what is that? Changing pressure. Here this is called as a changing momentum. But this del P is known as the changing pressure. Changing pressure is equal to rho V E. Okay. So rho V U. Then changing pressure. How to find out that? So the piston is pushed or pulled. The compression and draft action of longitudinal waves is alternately is produced. Okay, so that more or less we have to calculate. Already we studied in 7th chapter also that changing pressure is equal to bulk modulus into actual changing volume by actual volume. So del P is equal to B into del V by V. Then V is equal to volume. Volume is equal to area into distance. So area into del x or A into del x, you can substitute that V into del T. Then changing volume V del V is equal to area into piston how much distance it's moved. So that is del D, and A into del D you can substitute U into del T. So both the equations you can substitute this equation. So changing pressure del P is equal to bulk modulus B. B is the bulk modulus B into del V. A U into del T divided by A B into del T. So del T cancel, A cancel. Then changing pressure del P is equal to B into U by V. Changing pressure del P is equal to B into U by V. But del P, what is that formula? We found that the rho VU. So rho VU is equal to BU by V. U cancel and remaining rho VU is equal to BUV, UU cancel and remaining terms rho V is equal to B by V or B is equal V squared is equal to B by rho or V is equal to square root of B by rho. So velocity is depends upon that bulk modulus and density. So velocity is depends upon that square root of bulk modulus and density. So velocity is directly proportional to the square root of bulk modulus and inversely proportional to the density of air. Okay, and case for solid, suppose, so this is the velocity of longitudinal waves in an elastic medium. So velocity of longitudinal waves in an elastic medium, the formula is velocity V is equal to square root of B by rho. Velocity is elastic medium. Velocity of longitudinal waves in an elastic medium V is equal to square root of B by rho. Suppose some special cases is there. So in solid, for a solid, first one we can take that one dimensional rod. So that one dimensional rod velocity is equal to square root of Young's modulus divided by rho. For Young's modulus velocity, you can suppose we can calculate that elastic one rod. Okay, so one dimensional rod means the velocity is equal to square root of y by rho. Y is the Young's modulus. And second one, suppose this is the one dimensional rod. Suppose I can take that three dimensional rod. So suppose if we take that three dimensional rod means the velocity is equal to V is equal to square root of 1 plus 4 by 3 eta by rho. And next, for a solid case, this is the solid case. Suppose that elastic medium in a liquid means, that velocity is equal to square root of bulk modulus divided by K by rho. V is equal to square root of K by rho. So this is called as a velocity of longitudinal waves. Do you understand, ma'am? Okay, thank you.